Module 4, Lecture A, Summarizing Records. By the end of this lecture, you will be able to calculate counts, totals, averages, minima, and maxima from small medical datasets, group records by clinical categories such as ward, diagnosis label, or risk status, and use standard library tools to simplify accurate summary calculations. Basic medical statistics. Core summary measures. Core summary measures turn individual medical records into useful clinical information. Counts, totals, averages, and minimum and maximum values describe key patterns such as patient volume, resource use, typical measurements, and extreme observations. Together, these measures give clinicians and researchers a concise overview of a dataset and connect the data to clinical questions. When analyzing small medical datasets, first clarify what each record represents, such as an admission or a lab result, because that changes how counts and averages should be interpreted. Treat missing or unusual values carefully. A blank discharge date may mean the patient is still admitted. 0 age may be valid for a newborn, and a very high glucose value may reflect a real emergency. Good summaries combine accurate calculations with clinical judgment. Basic summary measures can reveal patterns that individual records may hide. Totals, averages, minimums, and maximums help healthcare teams understand demand, patient needs, overall function, and unusual extremes in settings like emergency care, rehabilitation, and diabetes management. These metrics do not replace clinical judgment, but they provide a structured way to ask better questions and communicate findings clearly. Python code. Core summary measures. Summaries convert clinical records into useful measures. With small datasets, the calculations are easy to check, and built-in functions help produce quick, accurate results. This note means the code runs using only Python's built-in features, so no extra packages are required. That makes the script simple to set up and useful for quick analysis or educational use. The data is organized as a list of patient admission records. Each record stores the ward, patient age, length of stay in hours, and systolic blood pressure, making the information easy to access and analyze. First, count the patient records by finding the length of the admissions list. This total is needed to calculate averages and check that the extracted data is consistent. We extract key patient data from the admissions records into separate lists: ages, length of stay in hours, and systolic blood pressure readings. Organizing these values this way makes it easier to calculate and analyze each measurement across all patients. This check confirms that each data list has the same number of entries as the total record count. It compares the lengths of the age, stay hour, and systolic value lists, and the result is true only if they all match. This helps verify that the data is consistent across all records. The analysis summarizes patient admissions by calculating 3 key measures: total hospital stay time, average patient age, and average systolic blood pressure. Total stay hours come from adding all stay durations, while the 2 averages are found by dividing each total by the number of records. Use the minimum function on the stay duration values to find the shortest hospital stay, and the maximum function to find the longest stay. The maximum function can also identify the highest systolic blood pressure recorded. Together, these summaries highlight key clinical observations in the dataset. This summary checks the patient admissions dataset by first confirming the number of records and making sure each data list has the correct length. It then reports key measures, including total stay hours, average patient age, average systolic blood pressure, the shortest and longest stays, and the highest systolic blood pressure. Together, these values give a quick snapshot of dataset quality, hospital use, patient demographics, and important clinical extremes. This script summarizes a small patient admissions dataset by checking the record count, extracting key measures, and confirming the data stays consistent. It calculates total stay time, average age, average systolic blood pressure, the shortest and longest stays, and the highest systolic blood pressure. The results are printed as a compact clinical summary using only built-in tools and no external libraries. Core summary measures. Core summary measures turn medical records into useful insights. Counts show how many records are included, totals add values, averages describe typical results, and minimums and maximums reveal extremes. Together, these measures help summarize patient data and support the detection of clinical risks or errors. When summarizing data, choose measures based on what they reveal. A count shows the dataset size and gives context for other summaries, while a total is useful when the accumulated amount matters. An average describes the center of the data but can be distorted by outliers, and the minimum and maximum quickly show the overall range. Accurate medical summaries depend on choosing the right records and excluding irrelevant or missing values before calculating counts, totals, averages, or ranges. For example, patient age summaries should include only the intended diabetes group, and blood glucose summaries should separate fasting readings from post-treatment readings. Clear definitions and consistent data handling are essential for reliable results in both teaching datasets and clinical systems. Python code, core summary measures. Summaries help turn raw records into useful clinical information. Small lists keep examples easy to follow, while built-in tools safely calculate common measures. We create a list of hospital stay lengths, where each value represents one patient encounter. This organized data makes it easier to calculate summary statistics and turn raw stay information into useful clinical insights. To find the number of patient encounters, count the entries in the list of stay lengths. This total gives the number of records and provides the basis for accurate summary statistics, such as averages. The code finds the total hospital stay time by adding all patient stay durations in the list. It uses the sum function to combine the days from each encounter into one overall total. The code computes the average number of days by dividing the total days by the number of records, but only when records exist. If there are no records, it returns none to avoid a division by zero error. To find the shortest length of stay, use the minimum function on the list of stay durations. First, check that the list has data, so the function does not cause an error. If the list is empty, use none to show that there is no value to report. To find the longest patient stay, first check whether the stay duration list has any entries. If it does, use the max function to identify the largest duration. If the list is empty, return none to avoid an error. This line tells the user how many patient records were summarized. It uses a formatted string to insert the record count directly into the message, making the output clear and concise. This line displays the total bed days across all patient encounters. It places the total into a clear message, giving a concise summary of the collected clinical data. This calculates the average patient length of stay by dividing the total days stayed by the number of records. The result is shown to one decimal place, making it easy to read and useful for understanding a typical hospital stay. This line displays the shortest patient stay in days, using the minimum stay duration already calculated from the encounter list. The formatted message makes the result clear and easy to interpret. This line displays the longest patient stay found in the encounter list. It inserts the maximum number of days into a clear message, making it easy to identify the highest recorded length of stay. The script summarizes 5 patient stays by calculating total bed days, average length of stay, and the minimum and maximum stay durations. In this dataset, the total is 23 bed days. The average stay is 4.6 days, and stays range from 2 to 9 days. It then prints these key statistics as a concise overview of the data. Core summary measures. Core summary measures turn medical records into usable information. Counts show how many records, patients, or events are present, while totals combine values to reveal workload and resource needs. Even simple summaries can help identify patterns of care and support decisions, but they must be interpreted carefully so they reflect the true context of the data. Averages, minima, and maxima give quick summaries of a dataset by showing typical values and the overall range. They can help describe things like ages, stays, wait times, or temperatures without reviewing every record. However, because extreme values can distort these summaries, they should be interpreted carefully. With small medical datasets, first clarify what each record represents, such as a patient or a visit. Counts, totals, and averages can be misleading when entries are inconsistent or incomplete, so check that the fields match the question before summarizing. These basics support accurate work in areas like staffing estimates and patient flow analysis. Python code, core summary measures. Summaries help turn clinical records into useful information. Small datasets make calculations easier to check, while built-in functions support accurate, beginner-friendly analysis. We create a small hospital ward dataset as a list of patient records. Each record stores a patient ID, ward, length of stay, and waiting time, making the data easy to access, organize, and analyze later. The code adds 2 patient records to a small dataset. One patient is in a medical ward with a 2-day stay and a 35-minute wait, while the other is in a pediatric ward with a 1-day stay and an 18-minute wait. Storing each record as a dictionary in a list makes the clinical data easy to organize, manipulate, and analyze. A new patient record is added to the list as a dictionary containing the patient ID, ward, length of stay, and waiting time. In this case, patient key 005 is in the surgical ward, stayed 4 days, and waited 50 minutes. This record can then be used to calculate ward summary statistics such as total stay days and average wait time. We count the patient records by applying the length function to the records list. This tells us how many patient entries are available, which is needed for later averages and summary statistics. We extract 2 key sets of values from the patient records: the number of days each patient stayed in the ward and the waiting time for each patient in minutes. Collecting these values together makes it easier to analyze stay durations and waiting times, such as finding averages or extreme values later. Calculate the total stay time by adding all patient stay days. Then find the average stay by dividing that total by the number of patients. Similarly, calculate the average wait time by adding all wait minutes and dividing by the patient count. Use the minimum function on the stay days to find the shortest patient stay, and the maximum function to find the longest stay. Then use the maximum function on the wait times to identify the longest recorded wait. Together, these results summarize the range of stay durations and wait times in the dataset. The output presents a basic ward summary with key patient statistics. It reports the total number of patients, total stay days, average stay length, the shortest and longest stays, average wait time, and the maximum wait time. The averages are shown to one decimal place, giving a clear and concise overview of ward activity and patient waiting times. This script summarizes a small set of patient records to give a quick view of ward activity. It counts the patients, analyzes their length of stay and waiting times, and reports key measures such as total and average stay, shortest and longest stay, average wait, and maximum wait. These statistics help describe patient flow and ward resource use. Grouping clinical records. Grouping by ward. Organizing clinical records by ward groups patient data according to where care is delivered, such as the emergency department or intensive care unit. This preserves the clinical meaning while making hospital activity easier to compare across units. It helps managers and analysts quickly see patterns, such as patient volume, discharge rates, and units with higher admissions or more complex care needs. When grouping patient records by ward, analysts must make ward names consistent and decide the right level of detail for the analysis. Different labels may describe the same unit, while some wards may need to stay separate for specific questions. Detailed categories can support staffing analysis, but broader groups may be better for hospital-wide patterns. Good grouping requires both accurate data handling and an understanding of how the hospital is organized. After patient records are grouped by ward, summaries can show key measures such as patient volume, age, medication use, length of stay, and risks like falls or infections. These patterns help staff understand differences between wards, such as higher risk levels or faster patient turnover. Interpreting the results in context gives hospital teams a clearer view of patient needs and service demands. Python code. Grouping by ward. Before summarizing patient records, group them by ward label. Small dictionaries can represent each patient row, and standard library counters provide a clear way to count and summarize the grouped records. The code imports the default dictionary tool from the Collections module to organize patient records by ward. This type of dictionary automatically creates a starting value for new keys, so records can be added to each ward group without first checking whether that ward already exists. We create a list of dictionaries to store hospital records. Each record holds key patient details such as identifier, ward, length of stay, and risk level, making the data easy to manage and use later. 2 new patient records are added to the dataset: patient P003 in the ICU with an 8-day stay and high risk, and patient P004 in the surgical ward with a 2-day stay and moderate risk. These records help organize patient information by ward for later grouping and summary. 2 new patient records are added to the larger records list: one for patient P005 in the medical ward with a 6-day stay and high risk, and one for patient P006 in the surgical ward with a 4-day stay and low risk. Storing them this way keeps the data organized for grouping and analysis by ward. A default dictionary from the Collections module can group hospital records by ward without first checking whether each ward already has a list. As each record is processed, its ward name is used as the grouping key, and the full record is added to that ward's list. This organizes patient records by ward, making later analysis or summaries easier. The program prints a header, then reviews patient records grouped by ward in alphabetical order. For each ward, it gathers the patient's hospital stay lengths, setting up later calculations such as average stay duration and risk levels. For each patient group, count how many patients are labeled high risk, then calculate the average length of stay. The average is found by adding all stay durations and dividing by the total number of patients. For each ward, create a short summary that includes the ward name, total number of patients, average stay length rounded to 1 decimal place, and number of high-risk patients. This gives a quick, clear overview of key patient statistics for that ward. The code prints a short summary for each ward, showing the number of patients, the average length of stay, and how many patients are high risk. This gives a clear overview of patient distribution and risk levels across the wards. This script groups patient records by hospital ward using a default dictionary, then summarizes each ward. For every ward, it reports the patient count, average stay duration, and number of high-risk patients. The results are sorted by ward name to give a clear overview of patient distribution and risk across the hospital. Grouping by ward. Grouping hospital records by ward turns individual clinical events into practical summaries for daily decision-making. It helps reveal patterns in patient needs, workload, demand, and length of stay across different care areas. This preserves useful clinical context while making the data easier to understand and act on. When summarizing records by ward, first make sure each record is assigned to the right standardized ward label. Different names for the same ward can create false separate groups and distort results. Also account for patient transfers and choose a grouping approach that matches the clinical question, such as where events happened, the ward responsible at the end of the day, or the discharge ward. Grouping hospital records by ward helps teams compare workload, monitor safety, allocate resources, and detect unusual changes. It supports questions such as where pressure points exist or whether a project has had an impact. These summaries must be interpreted carefully because higher incident counts may reflect a larger patient population rather than poorer performance. Python code. Grouping by ward. Group ward records into simple summaries using small examples to protect patient privacy and built-in tools to keep calculations clear. We import the default dictionary tool from the collections module to group and summarize data more easily. It automatically creates default entries, so each ward starts with totals of 0 for days, patients, and falls without needing to check whether the ward already exists. We create a list of dictionaries to store clinical records for hospital wards. Each record includes the ward name, patient count, and fall count, making the data easy to access, manage, and analyze. The code adds 3 daily ward records to an existing clinical dataset. They report patient counts and falls for the emergency, surgical, and ICU wards, supporting later summaries and analysis of patient and fall statistics by ward. This record adds daily data for the surgical ward, showing 16 patients and no falls. It is one entry in a set of ward records used to summarize patient counts and falls, helping analyze trends and resource needs. We create a totals dictionary for each ward with automatic default entries for days, patients, and falls set to 0. This lets new wards be added as they appear and makes it easier to accumulate totals while processing the records. The process goes through each record and groups the data by ward name. For each ward, it counts how many daily records have been processed and adds the current patient count to that ward's running total. This creates a summary of total days and total patients for each ward. This line updates the running total of falls for each ward. For each record, It finds the ward summary entry and adds that record's fall count, building the total across all records. The output begins with a header for the ward summary, then processes each ward in alphabetical order for consistency. For each ward, it uses the total patients and total days to calculate the average patients per day, giving a clearer view of patient load over time. The program builds and prints a short summary of ward records. It reports the ward name, total patients, average patients per day rounded to 1 decimal place, and total falls. To find the ward with the highest patient load, use the max function to compare each ward's total patient count. A key function tells it to focus on the patient total for each ward. After identifying the largest total, print a message naming that ward. This shows how grouping data by ward makes patient loads easy to compare. This script groups clinical records by ward to summarize patient activity and falls. For each ward, it totals the recorded days, patient counts, and fall events. Then reports total patients, average patients per day, and total falls. It also identifies the ward with the highest overall patient load, showing how grouping data can make key patterns easier to understand. Grouping by ward. Grouping clinical records by ward turns individual patient encounters into useful summaries for decision-making. By organizing data such as admissions, diagnoses, and ward assignments, staff can understand patient distribution, length of stay, readmissions, and resource needs for areas like intensive care or maternity. This helps teams see patient flow more clearly and plan clinical operations more effectively. When grouping clinical records by ward, ward names must be standardized so the same unit is not split across different labels. Inconsistent naming can distort summaries of workload, risk, admissions, and length of stay. Careful data entry and preparation make ward-based analysis more accurate and useful for operational decisions. Grouping patient records by ward helps hospitals understand care needs, staffing, capacity, and outcomes in the places where care is delivered. It can reveal issues such as rising oxygen demand in a respiratory ward or longer stays in a surgical ward, which may point to equipment needs or discharge delays. These summaries must be interpreted carefully because differences such as higher mortality may reflect sicker patients rather than poorer care. Python code. Grouping by ward. Grouping ward records helps create clinical summaries by organizing patient encounters into small lists. Built-in tools can then calculate key ward-level measures. We import 2 tools to summarize patient stays by ward. The default dictionary from collections helps group records under each ward automatically, while the mean function from statistics calculates the average number of stay days for each group. We create a small sample dataset that represents clinical records, with each patient stored as a record containing an ID, assigned ward, length of stay, and risk level. The data includes patients from medical, surgical, and ICU wards with different stays and risk levels. This structure makes the records easy to manage and prepares them for grouping and summarizing by ward. Two new patient records are added to the dataset: P005 in the surgical ward with a 4-day stay and medium risk, and P006 in the ICU with a 6-day stay and medium risk. These records will be grouped by ward to support ward-level summaries of patient data. The code first makes sure the records list is not empty. If it is empty, it raises a value error to stop processing and signal that data is required. This prevents later operations from failing because there is no input to work with. A default dictionary is used to group patient records by ward, automatically creating an empty list for each new ward. As each record is processed, its ward is identified, and the full record is added to that ward's group. This organizes the dataset by ward, making later analysis or summaries easier. The ward summary begins with a header showing key stay statistics, patient count, total days, average stay, and the shortest and longest stays. The wards are then processed in alphabetical order for consistent output. For each ward, the patient's stay days are collected to calculate these statistics, and the number of high-risk patients is counted to give a quick view of risk levels in that ward. The code builds and prints a short summary for each ward. It reports the ward name, patient count, total stay days, average stay rounded to 1 decimal place, shortest and longest stays, and the number of high-risk patients. The final print statement summarizes the process by showing how patient records are grouped by ward. This turns individual patient details into location-based summaries, making it easier to see the overall situation in each ward. This script groups patient records by ward and summarizes key ward-level statistics. For each ward, it reports the patient count, total and average stay length, shortest and longest stay, and number of high-risk patients. The result gives a quick overview of patient distribution and ward performance from individual patient data. Helpful summary modules. Standard summary tools. Standard summary tools turn individual medical records such as patient visits or lab results into useful data descriptions. They quickly count, total, and average values, reducing manual errors from missing or inconsistent data. This lets analysts focus on the clinical question and whether the data is ready for analysis. Standard summary tools make data work clearer, more consistent, and easier to check. In healthcare, tasks like totaling occupied beds, averaging wait times, or summarizing blood pressure readings rely on similar operations across different roles. This consistency matters because even small summary errors can affect decisions and how patterns are interpreted. Before using summary tools, make sure the data is complete, numeric fields are handled correctly, and missing or unusual values are checked. Automated summaries can speed up calculations, but they may be misleading if the underlying medical records contain gaps or errors. Accurate analysis depends on combining these tools with careful judgment about data quality and context. Python code. Standard summary tools. Summaries help clinicians quickly review small sets of records. Standard modules also reduce repeated calculations, and this example relies on safe built-in tools. We begin by importing a few tools needed for data analysis. Counter helps count item occurrences, while default document supports easy data aggregation with default values. The mean function calculates averages, and the date tool lets us work with admission dates in the dataset. We define patient visit data as a list of records, where each record stores details such as ward, risk level, age, bed stay, temperature, and admission date. This structure keeps the information organized and makes it easy to access and analyze later. The code first checks whether the records list is empty, because summarizing an empty dataset would be invalid and could cause errors. If no records are present, it raises a value error to indicate that at least one record is required before processing can continue. The code uses list comprehensions to pull key fields from patient records, including ages, bed stay lengths, temperatures, and admission dates. Creating these separate lists makes it easier to calculate summaries and analyze each field later. We use the Collections Counter tool to quickly count visits by ward and by risk level. This summarizes how records are distributed across both categories, making it easier to spot patterns or potential concerns in the dataset. Use a default dictionary with integer defaults to total bed days by ward. As each record is processed, identify its ward and add its bed days to that ward's running total. The result is a compact summary of resource use across wards. The code summarizes the patient records by counting total visits, adding all bed days to measure hospital resource use, calculating the average patient age to one decimal place, and finding the lowest and highest recorded temperatures to show the range of patient conditions. The output summarizes the admission records by first showing the earliest and latest admission dates to define the time frame. It then reports visit counts by ward and by risk level in an easy-to-read dictionary form. Finally, it shows the total bed days accumulated for each ward. This script sums up medical visit records by calculating key dataset statistics, including total visits, total bed days, average patient age, and the range of recorded temperatures. It also counts visits by ward and risk category, totals bed days for each ward, and finds the earliest and latest admission dates. The printed output gives a quick overview of the main characteristics of the dataset. Counter summaries. A counter is a standard library tool that quickly counts how often each value appears in a dataset. In medical data, it helps summarize categories such as patients per ward, diagnoses, admission routes, or test results. By tallying repeated labels automatically, it reduces manual errors and makes raw records easier to interpret. Counter summaries show how often each category appears in a dataset, making repeated categories easy to analyze. They can quickly reveal patterns such as patient acuity levels, discharge destinations, or incident types, while keeping each category linked to its count. They also help identify unexpected values, like typos or outdated categories, so data can be cleaned before reporting. Counter summaries make datasets easier to check by showing how many entries fall into each category. In medical data, this helps catch small errors that could affect analysis of workload, risk groups, or diagnosis patterns. They also support deeper investigation by revealing common labels and unexpected category frequencies, encouraging a more careful and logical review of the data. Python code, counter summaries. A counter can quickly summarize repeated medical categories in small ward records. These counts make it easier to check how the data is distributed. We import the counter class from Python's collections module to count how often items appear in a dataset. Counter works like a specialized dictionary for hashable objects, making it useful for quickly summarizing category frequencies. We create a list of ward labels, where each patient record is assigned a ward type, such as intensive care, medical, surgical, or rehabilitation. This lets us count how often each ward type appears and understand how patients are distributed across medical categories. The counter tool from the collections module counts how often each ward label appears in the list. It produces a dictionary-like result that pairs each ward name with its frequency, making it easy to see the distribution of ward categories in the data. To find the total number of records, add up all ward count values. These counts come from a counter that tracks how often each ward label appears. This total helps summarize the overall distribution of ward categories in the dataset. First, a header is displayed to introduce the ward frequency summary. This tells the user that the following output shows how often each ward category appears in the dataset. The code summarizes ward categories by frequency. For each category, it calculates its share of the total records as a percentage, then prints the ward name, record count, and percentage rounded to 1 decimal place. This gives a clear overview of how records are distributed across wards. The code prints the total record count as a final check. By showing the combined ward counts, it confirms that all entries were processed and the results are complete. To find the most common ward category, use the counter object's most common method. It ranks categories by frequency and returns the leading category with its count, making it easy to see which ward appears most often in the dataset. The code reports the ward category that appears most often in the dataset, along with its count. It uses the previously found most common result to give a quick summary of the dominant ward label. This script uses Python's counter tool to summarize patient ward labels. It counts how many records belong to each ward, reports each ward's share of the total, confirms the total number of records, and identifies the most common ward category. This provides a quick, efficient check of category distribution in a small dataset. Default dictionaries. Default dictionaries make data summaries easier by automatically setting up values for new categories. In medical datasets, this helps when ward names or diagnosis labels appear over time. Analysts can then count visits or add lengths of stay without extra checks, making the work simpler and less error-prone. Default dictionaries make it easier to group and summarize data because each category starts with a useful default value. They can automatically collect patient records by ward, add medication dose totals by drug, or track highest and lowest values within categories. This helps keep related values organized and makes summaries such as waiting times or bed days more consistent and efficient. Default dictionaries make clinical summaries clearer by separating data organization from analysis. They help you group records or total values first, then compute results such as counts or averages. This reduces bookkeeping errors and makes comparisons like ward lengths of stay more transparent, while still requiring careful interpretation of the data. Python code default dictionaries. Default dictionaries make it easier to group and summarize medical data by giving each missing category an automatic starting value. In this example, they are used to summarize short patient records efficiently. The script imports the default dictionary class from the collections module to make grouping data easier. It automatically supplies default values for missing keys, so patient records can be summarized by ward without extra checks. The data is organized as a collection of patient records, where each record stores the hospital ward and the number of days the patient stayed there. This structure makes it easy to work with patient stays by ward and duration. A default dictionary from the collections module can automatically create a new list when a missing key is used. This lets you add items to each key's list without first checking whether the key exists. It is a simple way to group data by category while avoiding extra setup code. The process loops through each patient record, takes the ward name and length of stay, and groups the stay durations by ward. A default dictionary makes this simpler by creating an empty list automatically for any new ward, so the values can be added without extra key checks. For each ward, sorted by name, the process summarizes its stay data by counting records, adding the total days, and calculating the average stay. It also identifies the shortest and longest stays. The final output reports these key statistics for each ward, with the average rounded to 1 decimal place. This script uses a default dictionary to group patient stay records by ward, without needing to check whether each ward already exists. It then summarizes each ward by counting the records and calculating total days, average stay, and the shortest and longest stays. The result is a clear ward-by-ward overview that makes the patient data easier to organize and understand. In this lecture, you learned to calculate counts, totals, averages, minima, and maxima from small medical datasets. Group records by clinical categories such as ward, diagnosis label, or risk status. And use standard library tools to simplify accurate summary calculations. In the next lecture, Lecture B, we will go over reports and audits.
Thank you for your attention. See you all in the next lecture.